Good morning, everybody. Thank you for joining Flex Train again, a flexible training opportunity brought to you by Johnstone Supply. So last week we were talking about static pressure and effects of static pressure on systems, and especially as they pertain to different blowers that we're working with, whether it be PSC or whether it is an ECM constant torque based or a true ECM variable speed. And we have different consequences because of poor ductwork and because of high static pressure. So as we progress forward talking about static pressure, and later we'll actually get into some more duct design this month, but we want to talk about zoning, and in particular zone controls and different styles of zone controls, because not all zone panels work with all pieces of equipment. And as technology is changing, we have to be very aware of the changes that are happening in the industry as a whole. And you guys know I love technology. That's where I came from. Everything that I worked on was based on technology and remote access, and using pressure transducers and temperature sensors to look at every operating aspect of our pieces of equipment. We're bringing that technology into the residential market, into residential applications, because of efficiency standards, because we've proven in the commercial industrial applications that we can get more efficiency out of our pieces of equipment, and we can improve comfort levels by bringing varieties of technology into the mix. So in the past, when we've talked about zoning, it's been very simple. We used a standard 24 volt in, 24 volt out controller that we would use multiple thermostats depending on how many zones we would have, and then we would control dampers to open and close certain portions of our ductwork so that we could maintain temperature in an area. When we're talking about a PSC motor that just comes on and blows a specific amount of CFM based on its static pressure, it wasn't very complicated. The only thing we really had to contend with is what happened when you close off one zone and you increase the static pressure on your blower. So most of the time in the past, we worked with bypass dampers and barometric bypass dampering to help modulate and control how much static pressure we're putting on our blower when those zones are actually opening and closing. Because it's all about creature comfort, isn't it? The only reason we add zoning into a system is so that we can control different areas at different temperatures. Because really, when the system is on, we're trying to control a consistent temperature in the entire structure, but we may not want consistent temperature in the entire structure. We may install a zone system to maintain consistent temperature, or we may install a zone system so that we can maintain separate temperatures. If we have an area that we want to have 4 or 5 degrees different than the rest of the house, we have to have a means of controlling that. What we did is we simply took our application, gas furnace, electric furnace, air handler, whatever we were using, and we used zone dampers on our supply side, and then we used a barometric bypass damper to help balance off that pressure. Let's do some polls real quick, because we got new guys, we have older guys, we have a variety of different skill sets that are on this training program today. If we're talking about barometric dampering, how many of you, now remember, we have to be honest with this program, because if we're not honest, we don't have a program to teach from. This is not polling by individual responses, it's just polling in general so that we can all look at a total poll. So I'll give it just another minute or two.
Good question.
Yeah, a bunch of shy people this morning. So far, only 22% of the people have voted. Oh, I love this. This is great. Okay, so we're going to stop right here. 43% of the people online have voted. About 70% have said that they have never been taught. 25% say they did not know that you had to adjust that. So that was kind of how I was introduced into barometric dampering. I was in the field for about 3 years, and I was out on a job that had some ductwork changed on it. It was a 2-story with a full basement over in the Franklin College area, Franklin, Indiana. And they were having some air control issues after their ductwork was changed because they did some renovating to the house, and the contractor came in, moved some ductwork, added some ductwork, removed, they did a lot of changes to the ducting of this house, and still had the existing same 3 zones on that system. And actually, I think I've so it had an old master control system on it. So this is a relay-based control network. As a young technician, this was a whole new animal for me. At that point, I was just getting into the residential and light commercial. It was a completely new atmosphere for me to learn. And so I studied this thing. I had a 16-inch barometric damper on this thing. It was a 5-ton system. Yeah, it was a monster. And and later on, I learned exactly why that was so. I had one zone that had like 400 CFM on it, on this 5-ton drive. So they had to have a means of doing bypassing, because what it all comes down to, guys, is that bypass damper is what we're going to use to help control external static pressure on that blower when we only have partial zone opening. So what was happening on that particular system, it was exactly like this is here. I had one common return, but I had a 16-inch barometric damper with a weight on it that was like, the arm was like 2 foot long on this thing. And what it was, the intentions of using a barometric damper is, so say we got 3 zones on this house, and only one of those zones calls, and it's got 400 and some CFM on it. And on that old system, that was a PSC motor 5-ton drive. I would have probably, if I knew how to check it at that point, which I didn't understand exactly what I was looking at, if I would have checked it, I guarantee if I wouldn't have had some kind of way of bypassing air, I would have had well over 1 inch of static on that system, which has put an excessive load on that PSC motor. So we use a biometric damper to actually control pressure. So we're going to open our smallest zone, and we're going to adjust our barometric damper to bypass air pressure back into that return so that we can balance the external static load that is on that blower motor. It's all about bypassing that air. The downfall of using any type of a bypass damper is now we have taken conditioned air and we're dumping it right back into our return. So, Greg, I know this was your world. Do you want to dive into bypass dampers anymore?
Well, I know that when we used to put them in, they did such a poor job of actually adjusting them that the 90% of the time the weight would keep the barometric closed.
Exactly.
Whereas if you want to do a simple rule of thumb, we would simply go out, open one of the 2 dampers, and then make sure that the bypass actually swung open to relieve the static pressure to at least a 0.5.
Exactly.
An easy way to do it is just to open all the zones and make sure that the damper remains closed. And then you start adjusting per zone. But like you said, if you put a dual port manometer on it, Clifton, you can actually keep the static pressure where the system was designed, which is a 0.5 or below.
Right.
So
exactly.
That's how we were taught to adjust the barometric bypass, to maintain a 0.5 or lower static pressure on the blower.
It's all about controlling that external static pressure. That's what we dove into last week, was talking about how external static pressure affects these blowers. Because you got to think about that. Even though I had a 5-ton drive, if I had no means of bypassing that air that I was not using, that additional 1600 CFM, I would now have an excessively high static on my blower motor, which is going to affect its total air performance, which in that particular case, we wanted less airflow. But the downfall is we created all the excess load on that motor in that instance. So that's what we had. That's all that we had to work with when we're talking about zoning, is simple zone systems that would open an area. It would allow one particular section of our ductwork to flow, and the rest was just left with nothing. It was actually getting bypassed through our barometric bypass damper back into the system so that we could maintain air pressure. Now we've got fully conditioned air going back into the return of this piece of equipment. So as we started moving forward in our technology, we had to start re-looking at different means of doing that. So, I want to talk about different brands real quick of zone controls, because most guys are familiar with just a simple 2 or 3 zone system that is just using a powered open or powered closed damper. So, out of curiosity, guys, let's take a poll on what is your zone control brand of choice. because it really is going to dictate the type of control that you have for your equipment. In the past, everything I installed was Honeywell. Johnstone, even at the corporate level, we are partnered with Honeywell. We do have Aprilaire available also. We can get Jackson, and we can now get EWC, which I really want to talk about as we move into this program. So 44% have voted, 75% say that they have used Honeywell, 25% say they use Aprilaire. No one has said that they use Jackson or EWC, which I find really interesting, because you guys know me. If I'm doing a class on a particular item, I want to tear this thing apart. I don't want to see the pretty box. I want to look at its innards, see what it's made out of. I want to go to a wiring diagram, because a wiring diagram is going to show me the capability of any piece of equipment that I'm working on. So if we talk about Honeywells and we talk about true zone systems, so like that HC 322, so it's a 3-zone high quality zone board from Honeywell. If we look at it internally, what that thing is actually capable of, it is very much like every zone control that we work with. We're going to, so if we're going to look up here in the top right hand corner, we're going to have, grab my handy dandy Sharpie again, we're going to have a thermostat controlling a damper. We're going to have a thermostat controlling a damper. We're not doing anything crazy with it. All we're doing is opening and closing devices, right? And then we're going to allow a barometric damper to help modulate that. That's fine when we're talking about pieces of equipment that haven't changed much over the last 30 years. We're talking about a zone control that works great on a conventional PSC or potentially a ECM constant torque based motor, where we're having major effects of high static pressure, and we're not communicating. Because remember, this is all legacy control. So this works great for a single or two-stage gas furnace and a single or two-stage AC or heat pump. But that's not what our industry is moving to, right? We all know what's happening with our industry. We all know the purpose of Daikin, why they came to the United States, is to inverterize the United States because of the efficiencies of these units. So we are moving into variable capacity, variable control, modulating, and communicating. So as good as these zone controls are for conventional zoning, they don't do anything for the communicating platform. And it's a shame, because I love Honeywell products. They have good zoning. They have good motors for their drives. We're now moving into the replacement motors, our power open, power close, so we can use a motor for multiple applications. Easy to have around, handy to have around. I love all that. No communicating. So what if we move into the Aprilaire or the Carrier? Because I don't know if you guys see that, but if you're Carrier dealers out there, that zone control looks pretty familiar because it's an Aprilaire. Same scenario. We're still talking about non-communicating zone controlling. Now, they do have communicating zone controls that are proprietary to manufacturers, because if we get into a Carrier Infinity system, we're going to be using a Carrier communicating zone control, and that's the only thing that's going to work for that, kind of. Same way with American Standard, Linux. So when we talk about that communicating platform, they all have their own specific communicating zone controls, where the traditional zone controls that are operating on legacy wiring through any of these brands is not going to function. And then we have Daikin out there that doesn't even have their own zone control. We're going to talk about that in a minute, though. And then finally, we have Amana moving away from that ComfortNet communicating system, going back into a legacy controlled thermostat. Now we're talking something that we can do. Now we can take a communicating modulating system and we can put a traditional zone control on it. Because remember, the zone control really is all about modulating a signal off from our thermostat. So it's really just a control. It's a secondary switch for our primary switch. But we don't want to use a bypass damper on a variable speed motor for any reason, because we're going to have a swing in barometric pressure on that thing. And we all know what a variable speed blower motor does when it's affected by the external static pressure. We talked about that last week. That variable speed blower motor, as soon as it sees a change in external static pressure, is going to significantly alter its RPMs to maintain CFM. What's that homeowner going to think about that? As that thing is modulating back and forth, they're going to give you a call and go, hey, man, that blower's just all over the place on my system. Every time a zone changes, I can see my curtains blow differently. And so that is true. And currently, I don't see a good alternative for variable speed blowers out of either Honeywell or Aprilaire as an aftermarket product. We do see an introduction once we move into, guess I blew that one, to like the Jackson IOs. Because if we're talking on a legacy system that's using a variable speed blower, if we can control that duct work and try to maintain our external static pressure very consistently, it's not going to affect the speed, the RPMs of our variable speed blower. And that's really what we're going to have to start focusing on. Going forward with our equipment, we're going to have to decide, are we working with a legacy system? Are we working with a communicating system? And are we working with a variable speed blower? Because they are all going to have effects on the type of zone control that we use. So Jackson it's a product out of Indianapolis, and I've used them for decades, particularly in the light commercial industrial side of things, because of the innovation that they have. They're simply like with that IO system, they are using a static pressure sensor that comes as part of that kit to monitor static pressure. And then they're going to use power open and power closed motors, which are the Belimo motors that they're, or Belimo motors that they're using on their dampers, so that they can actually proportion their dampers based on which dampers are open, which dampers are not, and you can set proportions for those dampers to be open. So instead of having a bypass damper, we can now actually bypass proportions of air through each one of those dampers. So you can go in, you can set a minimum standard for each of those zones, and now you can watch your static pressure. And once you get those minimum standards set for your zones, the static pressure is actually going to be now an input for that control board. And if it sees an elevation in static pressure, it can actually open and flutter open some of the other zones to help bypass off some of that external static pressure. So yes, you do push a little bit more air into zones that are not calling, but we're only talking fractional, only enough to affect our total external static pressure that is on the entire duct system, so that we can maintain a constant constant external static pressure on that blower. Very nice pieces of equipment. They've got great dampers. I've got some guys in the area, especially around the Indianapolis area, that will have me bring these in because they prefer these over the things that we have on the shelf. So I like to sell you the things that I have on the shelf, but I'm about the solutions. I'm about finding the things that are going to work and work effectively for the equipment that you are installing, whether it's mine or whether it's somebody else's. So, great piece of equipment. If we look at it, very simple layout, thermostats in, power open, power closed dampers, and then we have a lot of functionality into the control of how we want to fine tune this thing. So I would consider the Jacksons as being a commercial application that's been adjusted to work in a residential environment. Good warranty on the things. That's the dampers that they actually use for those modulating dampers. So let's get into the big question, because I have a lot of Daikin dealers on here. I see that. I've got some Amana guys. So you Amana guys are probably now rethinking your zoning a little bit, going, there's some options for zoning. The Daikin guys are the ones that are really struggling right now, because if we look at a Daikin communicating system, you know, we're talking about a system that actually stayed with that ComfortNet platform. Let's do another poll real quick. So if you guys aren't familiar with the Daikin, you may not have input on here, but I value your responses. So especially for the Daikin guys out there, can you zone a Daikin communicating system? Because right now, most of the Daikin guys out there, if they get into a communicating application, they are setting those up as a non-communicating platform because of zoning problems, because everyone has this issue with communicating zone controlling. So yeah, boy, we got all kinds of responses now. So 55% of the people online have voted, and it is split. 50% say yes, you can. 50% say they're just not sure. So let's talk about that. What are your options? Because it's a very, very big deal. Because now we're still talking about a communicating platform. And in the past, Daikin has not offered anything with that. Well, about a year ago or so, I found this company out there called EWC. And I seen Steve Wood from EWC pop in. Steve, are you still online? Let me see if I can find you on my list here. And there you are. Let me unmute you if you are interested in joining us.
Yes, I am joined.
Oh, fantastic. Thank you for joining us this morning. So I know this is your first time on our Flex Train. So this is a program where we just talk about things about HVAC. And about a year ago, I found this little board out there called an EWC UT3000. And that was back when Amana was still on the ComfortNet platform. So I was looking at that going, man, this is an actual communicating system for Amana that is actually successful for Daikin as well. And now that Amana has split away from the communicating platform and Daikin has stayed on the ComfortNet platform, raises a big problem if you have a communicating system, especially now that we are pushing the Daikin Fit like hotcakes. It's the best piece of equipment on the market, hands down. As soon as it comes out in heat pump version, one is going in my house. I've already told everyone in the Grammy group, when the heat pumps come, I want one, bad, like bad. I'll buy it, and it'll be the test pilot for me doing videos on. Downfall of a Daikin system is that it doesn't have a proprietary communicating zone control. Like all the other manufacturers have their own proprietary zone controls. Daikin kind of stayed away from that for one reason. That communicating zone control can be very, very expensive. And it was something that they had not perfected yet. And then along comes this little beauty of a zone control called an EWC UT3000 that is, I see, recently certified for the Daikin Fit. And after doing a little discussion with EWC yesterday, have found that this thing is actually now usable on the Daikin One Plus thermostat, which is the game changer. Because up until now, Daikin was having problems with the EWC communicating with the Daikin One Plus thermostat. Still worked great on the CTK04, but not with that Daikin One Plus thermostat. So here's the interesting thing about this EWC control board. And I had to actually dive into it just a little bit and figure out, Steve, the communication network that you're working with. And if I'm correct, we're talking about Climate Talk. We're talking about a technology that Emerson introduced for communicating HVAC equipment. Am I right? The base communication. Because not a lot of people in industry understand what that is. It is a phenomenal communication platform that I believe most manufacturers utilize, even for their communicating zone controlling. And because it stayed proprietary to most manufacturers, you're stuck using that manufacturer's zone control. And with this EWC zone control, it's using all of that networking to be able to communicate from the zone board into the rest of the equipment, the rest of the completely communicating, modulating equipment. And its input can be based on a communicating thermostat and a non-communicating thermostat. So it can actually use non-communicating thermostats for the basis of the commands for the communicating output signal. So what does that mean for a Daikin DCP? That means you now have a board, a zone control board, that you can use a Daikin One Plus master thermostat And your slaves can be anything that you want them to be. That is the world I'm talking about. That is why I came back to residential, because we're talking about a level of technology that no one has anything remotely close to in the industry. We're talking about technology that is starting to open up I/O platforms for our home automations. Because remember, guys, you hear me preach about this all the time. We are going into home automations. We are the lead industry to be affecting home automations for our consumers, because our equipment is very much moving that direction. If we look at the Amana platform, Amana moved away from ComfortNet into Comfort Bridge so that they can accommodate homeowners' pre-existing communicating intelligent home automation systems that already have existing thermostats. So now we're starting to lean into that direction, even in our communicating platform. So we have a zone board where we can use multiple thermostats, and we can get away from those expensive proprietary manufacturers communicating thermostats. Because if I have a communicating carrier system, I have communicating carrier thermostats in every zone. And so with the Amana guys, when these Amana dealers go out and bid jobs communicating systems, they are just tearing up the market, because now they can go back to legacy wired zone controlling. And then they can even upgrade into like Jackson style zone controlling. And now I see my EWC board and I go, these guys have got something that I appreciate, because I appreciate the world that we are moving into the residential market. So going forward, you can now utilize this board, which I've been pushing for 6 months, hot and heavy, to get into our Johnstone Grimmie locally, and hopefully it will be larger as it moves forward. Because right now, Steve, am I correct? This is the only zone control board on the market that will function with a Daikin communicating system.
You're correct, Clifton.
And I've been pushing this and pushing this and pushing this for our guys, and they haven't quite gotten the big picture of the Daikin communicating, because a lot of guys are still using the legacy communicating systems when they're working with zoning, even on some of these 18 and 20 SEER systems, which I very much disagree with, because you're losing the benefits of a true communicating piece of technology. And if you install a Daikin Fit, you don't have the option of operating that. That's 100% inverter with an electronic expansion valve coil that is fully communicating with whatever system that it is tied to, and it has to be Daikin communicating now. It can be on the CTKL4, or it could be on the Daikin 1 Plus, because they're still talking in that same DC communicating voltage, right? That same platform that's going to stay around, because they are going to continue. That is their focus now, is to stay with this. This Daikin 1 Plus thermostat is the thermostat that Daikin is building to replace every thermostat that they manufacture. Daikin 1 Plus will end up being a thermostat that will be a brand thermostat to function on all of their equipment, communicating and legacy. They're not there on the legacy side of it yet, but the communicating, we're here. We are pushing this thermostat already. So be mindful of the advances in technology and how we're going to be zoning those going forward, and start getting yourself familiar with the changes in the industry, like variable speed blowers and communicating systems, because we have other worlds that are popping up as well outside of these Daikin zone communicating systems. Because if we look at Daikin is very much about creature comfort and creature comfort control. You know, if we look at where Daikin comes from, they're very much an independent mini split and non-ducted society. So they're adapting their equipment to work here in the United States, and they're doing that in some other ways. So guys, here is your solution for a Daikin communicating system, plain and simple. If we look at some of the other systems that Daikin is going to, we're going into multi-zone ducting off from single outdoor units.
3 ton can do 4, then they have a 3.5 ton that can do 5.
Okay. until you get into the VRV. We have so many different combinations of equipment that I'm struggling keeping up on the technical service, let alone the design aspect of this thing, because Daikin is bringing so many different products into the scheme and different ways to apply those for zoning. So we can use multiple heads on single outdoor units so that we can get a variety of zoning. Well, now we're moving into the VRV Life system as well, which that VRV Life system is basically the same as a VRV 4S that has been converted to single phase operation to work in residential applications. So now we're talking about still a communicating system, but on a slightly different platform, because now we're going to be able to use, if we look at that top left one, we're actually using an electronic expansion valve cased coil on that Life system. So we can have a gas furnace with existing ductwork. And now we can add our additional zones by branching off from that single outdoor unit with our ref nets and bringing refrigerant line setting over to additional heads, varieties of different heads. We have cassettes, we have wall units, we have traditional wall-mounted split heads, we have ducted cassettes, we have high static pressure ducted cassettes, a whole myriad of applications that can be tied onto that one outdoor unit. So now we have on that flexible dual fuel system, that's up to 9 different components that we can have running on that system, all from one outdoor unit. So now we can move zoning into multiple indoor units based on the command from their controller and the command off from their main wall controller for your existing ducted system. We do not use even the communicating zone control on this stuff. So it's another animal all on its own. So as technology changes, that was the entire reason that we did this platform, guys, so that we can stay up to date on changes in the industry, so that you guys are preparing yourself for the changes that are coming. Because who wants to be that guy that moves into Daikin equipment and goes out and installs the first Daikin Fit, and they have an existing zone system? They go, hey, technical support, how do I tie my Aprilaire zone control into this Daikin Fit communicating system with a Daikin 1+ thermostat? You don't. So we need to be prepared as companies, as contractors, as technicians. We need to be prepared as we're going into this field what our options are, because we do have a lot of existing zone systems, especially here in the Midwest. I know I've got people online today from all over the country. Some of you guys out there are like, zone controls? Like, commercial, we don't have zone controls in residential. Other places you have lots of them. Here in the Midwest, we have a lot of zone controls. And so now we have existing zone controls that have to be updated to be able to work with the equipment that we are now going to be installing. So lots of stuff to discuss when it gets into zoning. We could spend so much time on this. So I think we'll take a break from that for a second. And let me, I'm going to open up our mics just for a second. Hopefully we don't have too much background noise. How many questions? Greg, are you still out there?
I'm here, Clifton. Actually, I wanted to follow up on some of the things you said about Daikin, if I may.
Yeah.
You know, when you talked about how they have the mini split type heads in most of their applications in Japan, it's because they pay about 5 times what we do per kW over there.
Yes.
And when they joined the United States market, or when they researched it, they came over here and started researching our homes and our duct systems, which they found to be the #1 problem. And their top 3 concerns were airflow, airflow, and airflow.
Yes.
And that's what I heard from the engineer at Daikin. So he was kind of
Right.
like, basically, he made us sound like we were still in the Stone Ages when it came to HVAC.
We
And
are
kinda were, if you
airflow.
think about it. Me and my wife are empty nesters. We heat a 2,500 square foot house, and we stay in one room the entire time. So that's where technology is going, not only to match the airflow with the desired conditioning of what space we're in, but to match the equipment as well, so that the energy consumption matches the heat gain or heat loss of the structure. That's the world we're trying to get to.
Absolutely.
It's pretty fascinating too. I was on a Daikin Life yesterday, and kind of what you show in this picture here, the capability of matching an outdoor unit with a typical standard ducted system and some mini split heads, or what we call mini split heads as well, on the same exact system, which creates an incredibly efficient zoning, as it were.
Right.
That's it.
It's all about controlling that comfort level for our homeowners. And if we go in and we install a $20,000 modulating inverter system, they want to sit in their closet and be just as comfortable as they are sitting on their toilet. It's the reality of the world that we are in. So as contractors, as technicians, as designers, we have to be very aware of how our equipment is going to function with existing ductwork and existing zone controls. So you are going to be going into atmospheres now, re-looking at existing ductwork, re-looking at existing zone controls to see if they're even going to function with your new piece of equipment. All right, guys. Well, I think we're going to wrap her up today. I'm going to pack up and do some more meetings with Corporate Johnstone. And thank you all again so much for joining Flex Train. And we'll see you all next week, or we'll see you tomorrow on Amenidays. Bye, guys.
See you, fellas.